Welcome back, everyone. So you've been on this incredible journey, this deep dive into the mind-bending world of quantum field theory.
That's right, QFT. Quite a mouthful.
It is, it is.
Yeah.
And for anyone just joining us, it's basically like the best theory we've got right now for describing the universe at the tiniest level, particles, forces, all that jazz.
Think of it like the instruction manual for reality, but at the subatomic scale, where things get, well, fuzzy.
Fuzzy is an understatement. But the crazy thing is, it's ridiculously good at predicting how stuff behaves. Like, experiments match up with its predictions to an insane degree of accuracy.
Absolutely. I mean, we're talking like some of the most successful predictions in all of science, which is kind of the paradox.
That's exactly where we're heading. It's like this amazing tool, this incredibly precise calculator that can tell us what happens but doesn't actually explain reality? Or is it just, crunching numbers really, really well?
That's the million-dollar question. And it's a question that's been bugging physicists since QFT was first developed.
Okay, so let's get into it. One of the things that really jumped out from, all the research we did was this idea that QFT describes what particles do, but not necessarily what they are.
Right. It's like, imagine having the blueprints for a car, but you have no idea how the engine works. You can see all the parts, how they fit together, but the actual mechanism that makes it go, that's a mystery.
So we've got this super detailed picture of the quantum world, but we're kind of missing the engine, the driving force behind it all. And there's this one quote that really stuck with me. It was, "The explanation of why quantum mechanics and quantum field theory work lies in the machinery of reality."
The explanation of the machinery of reality does not lie in quantum mechanics or QFT. Quantum mechanics is itself an interpretation of reality.
Whoa, okay, so that's deep. What does that even mean?
Well, it's saying that QFT, it's powerful, don't get me wrong. But it doesn't explain the fundamental why. It just describes the how. It tells us these fields exist, these, quantum fields where particles pop in and out of existence. But what are those fields made of? How do they interact with space-time? That's still a giant question mark.
Okay, so it's like we have this amazing map of the quantum landscape, but we don't know what the mountains are made of or what lies beneath the surface.
Exactly. And then there's the whole issue of, the math behind it all. QFT uses these things called tensors to describe physical systems, which are basically like these multidimensional arrays of numbers. And those numbers, they're great for calculations, but can numbers really capture the continuous flowing nature of reality?
So it's like we're trying to describe the ocean using just a bunch of data points. We might get some sense of it, but we're missing the waves, the currents, the whole dynamic interplay.
Right, and that leads to another big debate in physics. How do we interpret QFT? Some physicists think it's a literal description of reality. Like those fields, those particles, that's exactly what's out there.
But others are more cautious, I guess.
Yeah, they see it more as a powerful tool, an incredibly useful model, but not necessarily the final word on what's really going on. Like in your research, there was this idea that QFT itself is already an interpretation. We don't need to further interpret it.
Yeah, it's like arguing about what a map really means when the map itself is just a representation of the territory, right?
Exactly. And to be fair, every scientific model is, in a sense, an interpretation, a way to make sense of the world using the tools we have. But with QFT, this question of interpretation, it just feels a lot more, urgent.
Urgent, why?
Because we're dealing with the most fundamental questions imaginable, like what is reality made of? What are the rules of the game at the most basic level? If QFT is just a stepping stone, where does it lead?
Okay, so that brings us to the big so what question. If QFT is this incredible calculator, but maybe not the whole picture, what's next? What are the next steps on this journey?
Well, for one, we need to keep pushing the boundaries of QFT itself, explore its limits, see where it breaks down, because those breakdowns, they often point to where new physics might be hiding. And some physicists, they're already venturing beyond QFT, exploring other theories like string theory or loop quantum gravity.
And those are trying to dig even deeper, right? Get at that underlying machinery we were talking about.
Exactly. They're trying to go beyond the map, so to speak, and understand the territory itself. And that's why this whole discussion about QFT being a calculator, it's actually really exciting.
Exciting. How so?
Because it means there's still so much more to discover. We're just scratching the surface of what's possible. And for all of you listening, for anyone who has ever looked up at the stars and wondered, what's out there, what's it all about, that sense of wonder, that's what drives physics forward.
And maybe, just maybe, QFT is pointing us towards a deeper, even more mind-blowing understanding of the universe.
Who knows? Maybe one day we'll be able to look back at QFT and say, wow, that was a really good calculator. But look how far we've come.
And on that note, I think we're going to wrap things up for today.